So today's lesson is about scatter plots, and this is an example of a scatter plot, and you just created one. And all we're doing now with the scatter plot is we're just combining a set of ordered pairs into a graph. Now, one of the neat things about this, we're eventually going to learn how you draw a line that signifies that, and then we're going to use graphing technology to find the perfect line that best fits that data. And that's what's really neat, because one of the things we're going to be using is a program called GeoGebra, and we're going to be plotting points just like this, and then what we're going to do is select the points, and then the computer will spit out the answer just like that. And so that's one of the really neat things that we're going to be doing. And so anyway, this is an example of a scatter plot. Notice it's got ordered pairs, and that's it. That's what a scatter plot is, a set of ordered pairs. And so today we're going to be looking at lots of things with scatter plots. And so this is a definition bivariate data. I really don't think you need to memorize this definition of bivariate data. If you think of the word bivariate, first of all, bi means two. Variate is a root word of variable. So two variables. And so notice what the definition is, data with two variables. Scatter plot is a set of bivariate data graphed in ordered pairs. It's also called a dot plot. Okay? And so one of the things we're going to talk about then is correlations. Positive correlation, and negative correlation, and no correlation. So a positive correlation basically means that the data increases over time. It's got a positive slope. Okay? A negative correlation means that the graph kind of decreases. It goes down. So if I were to draw a line that would symbolize the points, it goes down. And then no correlation just means everything's just kind of plotted everywhere. So as you're kind of looking, and if I were you taking notes, this is what I would do. I would write the word positive correlation, and I would draw a picture similar to this with the line going up. I would put negative correlation. Draw something like that with the line going down. And then I would put no correlation with a bunch of dots. And that should be enough to indicate what a positive, negative, and no correlation looks like. I don't think you need all these words here that we talked about, because I think the picture does it justice enough. So if you just want to have the positive correlation, the picture, the negative correlation, the picture, and no correlation and a picture, you should be good to go. Now, as you're jotting that down, I want you to think back to the very first slide we looked at. And I want you to think, which of the three would that fit? So, which of the three? So just be thinking. Yep, we'll go back and look at it after everybody's had a chance to write that down. So which of the three did that look like?
Positive.
Which of the three do you think? If I were to draw a line, is it going to go up? Is it going to go down? Or is there no way I can draw a line that would fit those points? What do you think? Let's go back and look real quick. If I were going to draw a line, what do you think is going to happen there? Am I going to be able to draw a line that's probably going to represent what's going to happen? Yeah, so, if you think about it, I actually think I could probably draw a pretty good line here. And I think the line's probably going to go somewhere about right in right here. Now, the thing is, if we would look at this over time, what do you think the line's going to do? If I would look at this and I had you plot it your freshman year, and then your sophomore year, and then your junior year, and next year is seniors, what do you think the line's going to look like? Yeah, positive. It's going to go up. And you generally have that. Okay, we're not all the same size. And so that's one of the things. We've got some that are smaller, some that are bigger. Okay? And none of you are overly big anyway, so that's one of the things. So anyway, that would probably be a positive correlation. Now, believe it or not, when you have young children like babies, they plot them on a national chart and then they rank them where they're at according to percentages. And they see, okay, where in terms of height does this child fit? And what they've done is they've used something like a scatter plot on a long range, and they have created these equations and these charts. So based on that, they'll tell you, okay, your baby is in the 50th percentile for weight, 50th percentile for height, and the other thing they measure you will never guess. They measure the size of the head. And you're probably wondering, well, why would they do that? They've shown that the size of your head kind of indicates a predictor for how big you're going to be. Okay, and so that's one of the things they measure. Now, Tara for height and weight is fine. Okay, she's right around, 50 to 70. The head size, she's been at like the 98th and 99th percentile in every time we went there.
Is that big?
I don't think her head looks that big. But the thing is, if you think about it, what that means when they talk about percentiles, if you're to take 100 babies, that means only 1 or 2 babies are going to have a bigger head than her. That's what a percentile is. And so when they talk about, when you get to national tests and they talk about, well, you were in the 70th percentile, what that means, if you arrange 100 students, you've scored higher than 70 of them. Okay, you're at that 70th percentile. So that's a little bit about percentiles too, and that's what's neat about graphing. But anyway, let's get back to scatter plots. Okay, so now we're going to talk about what is a line of best fit. Okay, and the line of best fit here is kind of that line that I drew in. Okay, you remember that black line from the first slide. And that is a line that closely approximates a set of data. And so I'm going to find the line that I think best represents that data. So I'm going to try and split the data a little bit, kind of draw it in the middle. And then what we're going to do is we're going to write a line of best fit, and we call that a prediction equation. And so that's why we did all that stuff with equations and writing them with points, because now we're actually going to look at a practical example of that. So what we did, section 3, section 4, we're going to now do in section 5. And I think you'll like this because this is like some really neat examples here. So let's go ahead and look at an example. The table shows the percent of U.S. households with internet access. Okay, look at that. In 1997, only 18% had internet access. Make a scatter plot and a line of best fit and describe the correlation. Okay, let X be the number of years since 1995. So X is going to be, remember, X is going to be your horizontal axis. Let me go ahead and use black. I'm going to go ahead and draw a line in here. Okay, so X is going to be my horizontal axis. And so if I think about things here, number of years since 1995. So if I'm talking about 1997, what would that be for X? X would be 2, right? So I know here that X is going to be 2, and this is going to correlate to 1997. Okay. Oh, still haven't gotten it small enough. Let's try it. There, let's see if that one works better. Not really, but that's okay. That's close enough. Okay, so 2000 would be what? Where would 2000 be? 5. So 2000 is going to be here. There we go. Where would 2001 be? 6. Where would 2003 be? 8. And where would 2007 be? 12. Oh, I'm going to run out of room. So anyway, well, we'll put 12 over here. Okay, we'll fit it in there on the end. And so now it says percent. So what I'm going to do for percent is I'm going to go by tens. So I'm going to go by 10, 20, 30, 40, 50, and 60. And all I'm going to do is plot points. Okay, so 1997 is going to be at 2, right? How far up am I going to go? 18. About 18. Now, this is all kind of approximations. You're not going to have it exactly. Okay, the next one, 2000, where am I going to be at? 40. So a little over 40. Okay, 2001. up at 50, so just well, we'll just put it real close to that line because that's pretty much where it's at. 2003, 54, so about halfway. And then 2007, 61, so probably right up about right here. And so in looking at that set of data, is that going to have a positive, negative, or weak correlation? Why positive? Because it's going up. Okay, and you should think about that. Internet access eventually is getting to almost every home. And so now what we need to do is we need to go ahead and draw the line of best fit. Now this is what's interesting. Every one of you could have a different line of best fit, and every one of you could be right. So that's one of the things. It's not like an answer that's we're all going to get the right, the same answer. But I'm going to try and draw a line that fits the middle, somewhere in the middle. Suggestion, make sure you go through 2 distinct points. Okay, so I'm going to say, I don't know, something maybe like this. Let's see, yeah, like that. The reason why I chose this, okay, is one, I had to balance out this low point up here. Okay, I had to balance out this point right here. And so that's kind of why I kind of took those and kind of tried to split the middle. I have this one here, kind of tried to split the middle. Okay. And so if you remember what I said, I'm looking for 2 distinct points. I went through a point here, here, here. Now the reason why you want to go through points is because what are you going to have to find when I find the equation of this line? Slope. Okay? And so now I'm going to look strictly at this purple line, yeah, there. I'm going to look strictly at this purple line, and I'm going to now write an equation. So you remember when we did this 2 days and 3 days ago, you would look at the line, and you would find the equation. And so to find the equation, remember what I'm going to do, first thing is find the slope. Slope is what over what? Rise over run. And so in this case, I'm going to pick any 2 of these points that I have labeled. So I could pick this point here and this point here. What's the rise? What's the rise? 10. Okay, divided by the run. What's the run here? 2. So what's the slope going to be? 5. Okay, so far so good. Now, how do I finish the equation of the line? There's 2 ways. Okay. One way is that I could just go ahead and extend my line down, in which case, where has it intersected the y-axis? 10. So what would an equation be if I would do that? Y equals 5x plus 10. Very good. Okay, that's one way. The other way is to pick a point and know that this point is 430. I have the slope here and a point here. So you could go through, yeah, you could do point slope form. That's one option. Another option is to sit there and say, oh, I've got 5x plus b. That's my slope intercept form. I could plug in 30 for y and 4 for x, and then solve for b, in which case you're still going to get 10. But that is your equation for your line of best fit. Questions on that? Okay, so now it says predict the percent of households with internet access in the year 2020. So if you remember, my equation was y equals 5x plus 10. X represented the number of years since 1995. So how many years is 2020 from 1995? 25. So I'm going to plug 25 in here for X. What do you get? 135%. Do you think we could have 135% of households?
Yes.
No. And so actually this is one of those in which over the long term that's probably not a realistic answer. But what that would probably tell us is that it would be really, really close to 100%. All right, any questions? Okay, so now, this is what we're going to look at. So if you want to follow along in your book, this is an example taken from your book. It's on the bottom of page 93. Okay, so the bottom of page 93. So why don't you, in your groups, go ahead and complete letter A. Complete letter A, just real quick in your groups. So the last thing we're going to do is we're going to talk today about a regression line. Now tomorrow we're going to do an activity with GeoGebra on the netbooks. Okay, so you can actually do that activity at home as well. Okay, and so first of all, a regression line. This is what's different than what we just did. We did the line of best fit. A regression line is different because a regression line is created by a calculator or a spreadsheet. And it is the actually best fit line that you could possibly draw. They do all of these calculations, and they determine that they've minimized the distance between the points in that line. So they have found the exact middle of the set of data points. Yeah, no, I know, but just kind of so you guys can just put it together. All right, and so now the correlation coefficient is otherwise known as R. And that's another thing that these calculators and computers can calculate. And based on what R is, that shows how well data are modeled by a linear equation. If R is close to -1, that means that it's a negative correlation, which if you remember, negative correlation means it goes down. If R equals 0, no correlation, which is like where all the data, are scattered everywhere. And if R is close to 1, that means there's a positive correlation. And so what we're going to do is we're going to use a program called GeoGebra. Now the nice thing about GeoGebra, it's free. So if you're wanting to do your homework at home with GeoGebra, it's free. It's not a very big program. You do have to download it though, but it's located at www.geogebra.org. And it does so many neat things. Oh my gosh. So anyway, tomorrow what we're going to do with the netbooks is we're going to go ahead and use GeoGebra. And what's the neat thing is we're going to type in the points, it's going to plot them, we're going to select the points, and then it's going to draw the line right through them. So, we're continuing with this lesson tomorrow. What I'm going to do is give you the lesson for the entire assignment, and so you can go ahead and get started. I suggest you have graph paper. I think that will help with your lines of best fit a little bit better. And so then your assignment, and like I said, we're going to continue on with this tomorrow with GeoGebra, but it's going to be on page 96, 3 through 11. This assignment will be due Monday. I really suggest, though, you start it tonight or today sometime. Graph